what happens at the edge of the universe? At first, it sounds like a simple question. Everything we know seems to have an edge. A country has borders. A planet has a surface. An ocean has a shore. Even our solar system has a distant region where the influence of the sun slowly fades into interstellar space. So naturally, when we think about the universe, we imagine it the same way. A gigantic cosmic bubble filled with galaxies, stars, planets, black holes, dust, radiation, and darkness. And somewhere, incredibly far away, there must be a final border. A place where the universe ends. A place where, if you could somehow travel far enough, you would reach the last galaxy, the last star, the final piece of reality, and then look beyond it. But according to modern cosmology, the universe may not have an edge at all. Not because it is too far away, but because the idea of an edge may not make sense in the way our minds imagine it. To understand why, we first need to separate two ideas that people often mix together: the observable universe and the entire universe. The observable universe is the part of the universe we can see from Earth. It is like a giant sphere surrounding us, with Earth at the center from our point of view. But that does not mean Earth is the center of the universe. It only means this is the region from which light has had enough time to reach us since the beginning of the universe. Light travels incredibly fast, about 300,000 kilometers per second. But the universe is not only enormous, it is also expanding. And because of this expansion, there is a limit to how far we can see. The universe is about 13.8 billion years old. So you might think the observable universe should have a radius of 13.8 billion light years. But it is actually much larger. Because while light was traveling toward us, space itself was expanding to today. The radius of the observable universe is about 46 billion light years. That means the full observable universe is about 93 billion light years across. The farthest light we can detect is called the cosmic microwave background. It is not a wall. It is not a physical surface. It is the oldest light we can see, a faint afterglow from when the universe became transparent for the first time. Before that moment, the universe was so hot and dense that light could not travel freely. It was constantly scattered by particles. So when we look far enough into space, we are also looking back in time. Eventually, we reach a point where the universe becomes impossible to see through. Not because space ends there, but because light from earlier times cannot reach us in a visible way. This is one of the most important ideas. The edge of the observable universe is not the edge of everything. It is only the edge of what we can currently observe. Beyond that boundary, there may be more galaxies, more stars, more planets, more black holes, and perhaps regions of space so far away that their light will never reach us. Not because they do not exist, but because the universe is expanding too fast. This means the edge we can see is more like a cosmic horizon. Imagine standing in the middle of the ocean. You can see only so far before the curve of the Earth hides everything beyond the horizon. The horizon looks like an edge, but it is not the edge of the ocean. It is only the edge of what you can see from where you are standing. The observable universe works in a similar way. Every observer in the universe has their own observable universe. If there is a civilization in a galaxy billions of light years away, they would see a different cosmic sphere around them. Their observable universe would include regions we can never see. And there would be parts of our observable universe that they could never see. So the edge of the observable universe is not a special place. It is not a border in space. It is a limit created by time, light, and cosmic expansion. But this leads to a bigger question. If the observable universe has a limit, what about the entire universe? Does the full universe have an edge? There are several possibilities. The universe could be infinite. That means space goes on forever in every direction. No matter how far you travel, you never reach an end. There is always more space, more galaxies, more darkness, more distance. This idea is difficult for the human mind to handle because we are used to objects having boundaries. A table ends, a room ends, a planet has a surface, but space itself may not be an object sitting inside something larger. Space may simply continue without limit. If the universe is infinite, then there is no edge. There is no outside. There is no final wall. There is no place where space stops and something else begins. But there is another possibility. The universe could be finite, but still have no edge. That sounds impossible at first. How can something be finite but have no boundary? The answer comes from geometry. Imagine the surface of the Earth. The surface of Earth is finite. It has a certain area. But if you walk in one direction across the surface, you do not eventually reach the edge of Earth. You can keep going, and eventually, if you travel far enough, you may return to where you started. There is no edge on the surface, no border where the surface simply stops. Now imagine something similar, but in 3 dimensions. The universe could have a shape where space curves back on itself. If you traveled in a perfectly straight line for long enough, you might eventually return to your starting point. Not because you turned around, but because space itself is curved. This is similar to the north of the North Pole problem. If you walk north on Earth, eventually you reach the North Pole. But once you are there, asking, "What is north of the North Pole?" stops making normal sense. It is not that there is a mysterious, forbidden land beyond north. It is that the direction north no longer works the same way at that point. In a similar way, asking what is beyond the universe may be asking a question that uses ordinary language in a place where ordinary language breaks down. If space itself is part of the universe, then outside the universe may not be a location, because location only exists within space, and space is what we are asking about. But our minds still want an answer. If there is no edge, then what is the universe expanding into? This is one of the most common questions in cosmology. We hear that the universe is expanding, and we imagine an explosion, something bursting outward into empty space, like a firework or a cloud of smoke. But the Big Bang was not an explosion into space. It was an expansion of space itself. The galaxies are not flying away from a central point through empty space. Instead, the distances between galaxies are increasing because the fabric of space itself is stretching. A common example is dots on the surface of a balloon. As the balloon inflates, the dots move farther apart. But none of the dots is the center of the expansion on the surface. Every dot sees the other dots moving away. This is similar to what we observe in the universe. Distant galaxies are moving away from us, and the farther away they are, the faster they appear to recede. But this does not mean we are at the center. It means space is expanding everywhere. Still, the balloon example has a weakness. A balloon expands into the air around it. So people naturally ask, what is the universe expanding into? But the answer may be nothing. Not nothing, as in empty space. But no outside space is required. The universe does not need to expand into something. Space itself can expand by changing the distances inside it. So if there is no edge and no outside, what would happen if you somehow traveled toward the edge of the observable universe? Imagine you had an impossible spaceship. You point it toward the most distant region of space we can see. You travel for millions of years, then billions. You pass the Milky Way's neighborhood. You leave behind familiar galaxies. The night sky changes. The constellations disappear. But you never reach a wall. You never reach a border. You never find a sign that says, "End of the universe." Instead, as you move, your observable universe changes with you. The cosmic horizon is always around you. Some regions that were once visible from Earth become hidden behind your new horizon. Other regions, which Earth could never see, become visible to you. The edge keeps moving because it was never a physical edge. It was always a limit based on your position and the time light has had to reach you. This is one of the most humbling ideas in science. The universe may be far larger than anything we can observe, possibly infinitely larger. And because of cosmic expansion, there are regions of the universe we will never be able to reach or see, even if we waited forever. Some galaxies are already disappearing beyond our cosmic horizon. Not because they vanish, but because the space between us and them is expanding so quickly that their light will never reach us again. So does the universe have an edge? The honest answer is, we do not know for certain. Current observations suggest that the universe is very close to flat on large scales. A flat universe could be infinite, but it could also be finite in more complicated ways. The problem is that we can only measure the observable universe. If the entire universe is much larger than what we can see, then its overall shape may be impossible for us to determine completely. It is like trying to figure out whether Earth is curved while standing in a tiny field. From your local view, the ground looks flat. But that does not mean the entire planet is flat. It only means the curvature is too small to notice from where you are. The universe may be the same. From our observable region, space looks extremely close to flat. But beyond what we can see, the full structure may be larger and stranger than we can test directly. So what happens at the edge of the universe? If you mean the edge of what we can see, then you reach the cosmic horizon. The oldest light, the limit of observation. the boundary of our knowledge. But if you mean the edge of everything, then maybe nothing happens there at all. Because there may be no there, no wall, no cliff, no outside darkness waiting beyond the final star. Only space continuing beyond our view, or space curving in a way we cannot easily imagine. The edge of the universe may not be a place you can travel to. It may be the limit of what can be known from here. And beyond it, there may not be an end. There may only be more universe.